In this video, we'll look at sections 2.3 and 2.4. So notice 2.3 is on absolute value, and we use, there we go, and we use number lines for context. So absolute value is coming into play because we're going to start to talk about operations on integers, and we'll want to think of the absolute value. We use that frequently to discuss how to perform the operations in a more algorithmic way. Okay. We also want them to understand the idea of absolute value as distance from zero, so that they can see that opposites have the same distance from zero, and so they can start to understand the difference between magnitude and the value of a number. So by magnitude I mean the absolute value of a number, so the length or the distance from zero, and we want them to be able to distinguish between a positive number and a negative number. They have the same magnitude, but they are different numbers. So it starts off with a context. The submarine dove 15 meters below the surface of the water. Okay, and notice now we're starting to talk about the specifics. So what integer best represents the submarine's location relative to the surface of the water? So we're more clearly defining that now. So if we're talking about relative to the surface of the water, negative 15 meters would make sense because it dove down from the water. Okay. What word indicates the sign of the number? Well, that would be dove. What does zero represent in this context? Well, that's the surface of the water. Okay. Then we have them plot the number n0 and find the relative distance, okay, or the absolute value. And then here we get into symbolic form. So basically writing the expression like this. So a few things they need to know, or where they sometimes make errors, is they'll put the negative on the outside of the absolute value, or they think they need to know that absolute value is like parentheses, and that we perform everything in the absolute value first. So if this happened to be, which it's not, but if this happened to be the opposite of the absolute value of negative 50, we would find this absolute value first. The two negatives wouldn't cancel, and our result would be negative 50. Okay, so let's move along. And now opposites and number lines. So we're going to do this with number lines as well. We'll touch on it when we talk about the chip model, which you'll see soon. But the idea with opposites and a number line is we want them to think of the opposite of a number as the reflection of the number with respect to zero, about zero on the number line. Okay, so you'll see we have them plot the number 5. Then we'd the reflection, the opposite, would be here. Okay, so the opposite of 5, or we'd say opposite of 5 for this, and then we could reflect it again. Okay, so we think of this, instead of just thinking of the opposite as the same as a negative number, we want to think of the opposite as an action that we can take on a number. And yes, it basically changes the sign, but we want to show that this relative distance from zero, meaning they have equivalent absolute values, applies as well. Okay. And notice you may see how this is helpful based on the pattern above. What do you think the opposite of negative 5 equals? So if they think about this reflecting, they'll see that two reflections cancel each other out, and you end up back at the original number. So that's, instead of just saying negatives cancel, okay, which we're going to try not to say, we can think of this as kind of taking the opposite as its own inverse operation. Once you do it once, if you repeat it, you get back to where you started. Okay, let's start on a new video for this next one.